Hello and welcome to today's video. Today's video is for Chapter 4, Section 6, which deals with the hypotenuse leg theorem. Okay. So for this one I'm actually going to not start out with the notes today. I just want to show you a geometry sketchpad thing that I did, and it helps you see why hypotenuse leg works. So we're actually going to talk about the donkey theorem to start out with. So here's what I have. I took parts of a triangle, and here's what I'm given. I'm given an angle, I'm given a side, and I'm given another side. Now, if the angle is between the two sides, then I know that I have a congruent triangle and there's only one triangle I can make. So obviously that's not the case for this one. What I actually have here is I have CBA, so this CBA is congruent to this CBA, and then I have BC, the red one, so this side is congruent to this side, and then I actually have CA. And so this side is congruent to this side. And if you take a look at the picture, you notice I start out with two triangles. Okay? So I actually have the donkey theorem. I have SSA or ASS, however you want to say it. And it doesn't work, not because there's infinite number of triangles I can make, but because there's two triangles I can make with this given information. And the easiest way to see them is with the radius of the circle. So I would have done angles B, and then I would have put BC on it, and then I would have taken my compass and I would have drawn all the possible points for where A must be, and you notice there's two places, A and A prime. So what I either get is, and let me get rid of the circle, a little easier to see, I either get this triangle right here, which would be one solution to the problem, or I get this big outside triangle, and both of these fulfill all the properties. Okay. And we've learned this before, so this isn't terribly interesting to us, but I want to show you that this actually does produce one triangle in one specific case. Okay. So here's what I'm going to do. I'm going to play around with the angle and the sides, and notice that I'll change how many triangles I can get. So if I make the angle, if I make the angle go up further, what happens is I end up getting no triangle, because what happens is the third side's not long enough to reach. And if I move this down, here's where I get two triangles. But if you notice, right as these two lines get closer and closer and closer together, and it's very hard with this to make it happen, right before they meet, see how close I can get, right, it's probably as close as what I'm going to get. What happens is right before that line is going to become tangent to the circle, and I'm only going to have one line. It's going to be the green line, and it's going to come straight down. And if you take a look at what this angle measure is, it's really close to 90 degrees. And if I could make it exactly 90 degrees, what would happen is I would only get one triangle. But in order for this to happen, it would have to be a right triangle. If I make it too far up, I get no triangles. If I make it too far down, I get two triangles. But if I make it so that that angle right there is 90 degrees, I end up getting one triangle, and this can actually be a congruence theorem. Okay? So now if you look at what I have, I still have this angle. I have that this is 90 degrees. That's going to be an important part of it. I have the hypotenuse, and I have to have one other leg. And so what this is going to be called is it's going to be called hypotenuse leg, because it works for any right triangles in which you know the hypotenuses are congruent, and you also know one set of legs are congruent. Okay? So it's the only time you can use the donkey theorem, and that is when you have a right triangle. Okay. So just like with the isosceles triangle, we're going to start out with some definitions. We have a right triangle here. A right triangle is any triangle that contains a right angle. And then the hypotenuse is the side that's across from the right angle. And then the other two sides are called legs. So the hypotenuse leg theorem, just called HL theorem, is If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So in order to use this, we do need right triangles, so you'll have to prove the triangles are congruent, and then you have to prove that you have the hypotenuse is congruent and you have one set of legs. You don't actually have to state that it's hypotenuse, but you do have to state that it's a right triangle, and then you can prove that the hypotenuses are congruent and one set of legs are congruent, and then you can use HL theorem. Okay. We are going to do the proof of this one in class, and this is a very long and complicated proof, and it's going to involve a construction on this figure. So we'll do this one in class. We're given two right triangles, and we want to prove that the two triangles are congruent. Okay. And then once we're done with that, we're going to do just a couple practice using the HL theorem. We're going to prove that the triangles are congruent, and then also using these. These are fairly simple proofs. The hardest thing we're going to do in class is proving the HL theorem. And that's it for today's notes. Thank you for watching. Have a great day.